Infinity is one of those ideas we think we understand until we stop and actually look at it. We imagine something huge, something endless, something our minds can barely wrap around. But the truth is, far stranger infinity isn't just really big. It behaves in ways that completely break our everyday intuition. Some infinities fit inside other infinities. Some are countable, some are uncountable, and some are so large they make every number you know look tiny. In this video, we're going to explore infinity in the simplest way possible with clean examples and zero jargon, so you can finally see just how mind-bending this idea really is. Infinity feels like a simple idea. It just means endless, right? But that simplicity is a trick. Because once you really look at infinity, not as a poetic idea, but as a mathematical reality, everything you thought you knew about size numbers, and even the universe starts to break. Infinity isn't just big. It's bigger than big. It's bigger than anything your brain evolved to handle. And the deeper you look into it, the stranger it gets. So let's take the idea of infinity apart, piece by piece, using simple examples, no jargon, and the clearest explanations possible. And by the end of this video, your understanding of big will never be the same. Let's start with the most basic idea. Infinity is not a number, it's a process. When you count, you can always keep going. 1, 2, 3, 4, and no matter how high you get there, will always be one more number waiting. You never arrive at infinity. You just keep moving toward it. Infinity isn't a place you get to. It's the fact that there's no final stop. That idea alone is enough for most people. But infinity doesn't stay simple for long. The moment you start playing with it, something bizarre happens. Let's take the first famous example, Hilbert's hotel. Imagine a hotel with an infinite number of rooms. Every room is full, no vacancy at all, but a new guest shows up. In an ordinary hotel, that's a problem. But in an infinite one, it's the easiest problem in the world. Just move the person in room 1 to room 2. Move the person in room 2 to room 3. Room 3 to room 4. And so on. Suddenly, room 1 is empty. You made space even though the hotel was full. If 100 new guests arrive, you can make space. If 1,000 new guests arrive, you can make space. If an infinite number of new guests arrive, you can still make space. Infinity is not like anything in the real world. It breaks almost every intuition we have. For example, infinity plus 1 is still infinity. Infinity plus 1,000,000 is still infinity. Infinity minus infinity doesn't equal 0, it's undefined. Infinity behaves like a strange, slippery, untouchable concept because it is. But this is only the beginning of the weirdness, because there isn't just one infinity. There are many infinities, and some infinities are bigger than other infinities. This idea feels impossible at first. How can you have something that's infinite, and then something even more infinite? To understand this, we need to look at sets of numbers. Let's start with the natural numbers, the counting numbers. 1, 2, 3, 4, and so on forever. This is an infinite set. Now think about the real numbers. Every number with a decimal point. Between 0 and 1 alone, there are infinitely many numbers. But here's the twist. There are more numbers between 0 and 1 than there are whole numbers in the entire universe of integers. This was proved by mathematician Cantor using something called the diagonal argument. But we're not going to use math jargon. Here's the simple version. Imagine you try to list every decimal number between 0 and 1. Even if you try forever, no matter how you list them, Cantor showed you will always miss some. You can always create a new number that wasn't on your list. Always. That means the infinity of real numbers is bigger than the infinity of natural numbers. Both are endless, but one is more endless than the other. Infinity comes in sizes. This idea blew people's minds in the 1800s, and it still blows minds today because it means infinity isn't a single idea. It's a landscape, a hierarchy, a tower of bigger and bigger infinities stretching upward without limit. But infinity doesn't just live in math. It shows up everywhere in reality, whether you notice it or not. Take the space between 2 points. Let's say you have a line segment, just a simple line. No matter how small it is, there are infinitely many points on it. Between any 2 points, there are infinitely many more points. Space doesn't feel infinite to us, but mathematically, it is filled with infinite structure. Or think of time. Between 2 seconds, you can divide the moment in half, and then in half again, and then again forever. A single second contains endless potential instants. Fractals also show infinity in real life. Zoom in on a fractal pattern, the deeper you go, the more detail you uncover, without ever reaching an end. Infinity hides inside the ordinary world. But infinity also creates paradoxes situations that seem impossible until you understand how infinite sets work. One famous paradox is Achilles and the tortoise. Achilles gives a tortoise a head start in a race. To catch up, Achilles must first reach the tortoise's starting point. But by then, the tortoise has moved a little ahead. Achilles must reach that point. Then the next, then the next. You can divide this chase into an infinite number of steps. But in reality, Achilles obviously overtakes the tortoise. The paradox comes from confusing infinite steps with infinite time. You can have infinitely many steps that get smaller and smaller, so small that they still add up to a finite amount. Infinity isn't magic, it's just different from everyday experience. And infinity raises the biggest questions we can ask. Is the universe finite or infinite? Does space go on forever? Are there infinite galaxies, infinite planets, infinite versions of you? No one knows for sure, but mathematically, an infinite universe is possible, and in some theories, even likely. And here's a twist that surprises almost everyone. Even if the universe is finite in size, the number of points inside it is still an uncountable infinity. Space at a fundamental level has infinite structure. We live inside infinity, whether we feel it or not. Infinity is also essential for understanding modern physics, probability, geometry, and computers. Even video games rely on concepts of infinite decimals and infinite loops. Infinity is everywhere, hidden inside systems we use daily. So, what does all of this tell us? It tells us that infinity isn't just big. It's layered, it's structured, it's diverse. It breaks rules, it creates new rules, it defies intuition. It changes how we see everything, from the smallest space to the largest universe. Infinity teaches us that reality is bigger than our instincts, bigger than our language, bigger than our imagination. It tells us there are sizes of endless we can't picture. It tells us that some infinities fit inside other infinities. It tells us that mathematics can describe things far beyond human experience. And ultimately, infinity reminds us that the universe is not limited to what we can easily visualize. Instead, it stretches beyond anything we can ever finish counting, understanding, or fully grasping. Infinity isn't a number. It's a doorway. And once you walk through it, the world and your place in it becomes much, much bigger. If this explanation made infinity feel bigger, stranger, and more fascinating than before, that's exactly what it's meant to do. Infinity isn't just a mathematical concept. It's a reminder that reality is far more mysterious than it appears. If you want more videos that take massive, confusing ideas and turn them into clear, simple stories, make sure to subscribe, leave a like, and let me know what you want. Explained next. Thanks for watching Plain Explain, where even the infinite becomes understandable.